Okay, now I would like you to connect the relationship between period, the amount of time it takes to go one complete cycle, and frequency, the cycles of a wave length specific per second. When we're talking about these things, we have to understand that frequency is cycles per second. So for you to complete one wave in 1 second, you have a frequency of 1. If you complete 2 waves in 1 second, then that means that you are completing 2 waves in that second. Therefore, the period it takes to go 1 would be 0.5. So look here, as we see a frequency of 1, that means that frequency we would have 1 and 1 complete second. So I'm going to bring out the timer and I'm going to push play, and I want you to watch. We're going to go from green to wherever the next green wave is. Okay, so notice this guy's back at the main position. He is a little bit past. This would be the trough of a wave. This would be the crest of a wave, and this guy is almost right there. So this would be a complete wave, and this would take 1 second. Okay, 1 wave and 1 second. The period of this wave is 1. The frequency is 1. But if I change this frequency to 2 and then reset it, restart, push play. Okay, notice. All right, this guy here comes down. There's a crest, there's a trough, and then the next identical point over here, which would be right here, would be 1 wave. Okay, then if I go over here and find 1 and 1, the next identical point, it took 2 waves in this 1 second amount of time. That means that the period of 1 wave is half a second. That's the relationship that you're identifying between frequency and period. Period is equal to 1 over frequency. As the frequency increases, the period decreases. The amount of time it takes to complete 1 wave length would decrease if you increase your frequency that you're getting the wave. That should make sense to you. Watch how many waves you have when you increase the frequency. So I'm going to start back down really small, and I'm going to push play. And notice, we barely even have a wave. I mean, we've got a portion of a wave here. This is taking ridiculously long. I'm going to increase, and now the wave is getting shorter. As I'm increasing the frequency, the wavelength is getting shorter. And we get shorter and shorter and shorter waves. What you find then, not only is the period of a wave inversely related to the frequency, but also the wavelength. The wavelength of a wave is inversely related to the frequency. As you increase the wavelength, you're going to reduce the amount of waves you get per second. If you decrease the wavelength, you're going to increase the amount of waves that you get per second. That is the relationship between wavelength and frequency and period and frequency. If you increase the wave, then it's going to take longer for that wave to be completed. That is a direct relationship. So period and wavelength are directly related, whereas frequency and wavelength and frequency and period are both inversely related. I hope that makes sense to you from that simulation.